Okay, so here we discuss about the observations. First point is that for given frequency, mu is greater than mu naught. It must be necessary unless the frequency which is less than threshold frequency, no any electrons are ejected from that metal surface. So electrons are ejected when the incident radiations must have the frequency greater than threshold frequency. Here the point arises that what is the threshold frequency? What is the threshold frequency? So threshold frequency is the frequency due to which the electrons are come out from the metal surface. They are ejected from the metal surface. But the frequency is less than threshold frequency, they are not to come. Okay. So we have required to frequency which is threshold frequency or greater than on it. But whenever it is less than the threshold frequency, it does not emit the electrons. Okay? It does not radiate the electrons. So therefore, this is a photosensitive emitter plane. Okay. So suitable frequency of radiations are incident on that plate, then the number of electrons are ejected. This number of electrons are collected by the collected plate, which is at positive potential. Due to this, the electrons are moved, and when electrons, rate of flow of electrons, it is nothing but electric current. So current I is recorded. So this is the first observation. Next, second observation. There was no time lag between incidence of light and emission of electrons. Whenever the incident of light takes place, within a 10 raised to minus 9 second, electrons are ejected. Incident radiation, emission of electrons takes place within a 10 raised to minus 9 second. So 10 raised to minus 9 second, it is time. So whenever the incident radiations fall, electric current flow, means electrons are ejected from the metal surface. But whenever the incident radiations stop, electric current also stop. Okay. So this is a second. There was no time lag between incidence of light and emission of electrons. Okay, just 2 minutes. Okay. Thanks to everybody. So look at it. Here we have already studied about the first observation. Second observation is that there was no time lag between the incidence of light and emission of electrons. Next, third point. Whenever we increasing the intensity of incident light, समजा जर इंटेन्सिटी जर आपण काय झाली इन्सिडेंट लाईटची जर वाढवली, so whenever we increasing the intensity of incident light, then photocurrent also increases. करंटची व्हॅल्यू सुद्धा काय होणार आहे, वाढत जाणार आहे. So whenever we increasing the intensity of incident light, current should also increases. So this is shows that which are linearly varies with one another. So this shows that photocurrent directly proportional to the intensity of incident. So this is the third observation. सो काय काय पाहिलं बघा आपण फर्स्ट ऑब्झर्वेशनमध्ये. When ultraviolet radiations was incident on emitter plate, when ultraviolet radiations was incident on an emitter plate, current I was recorded even if the intensity of radiation was very low. So photocurrent I was observed only if the frequency of incident radiation was more than some threshold frequency, that is nu naught. So nu naught was same for a given metal and was different for different metals used as the emitter. So for a given frequency nu is greater than nu naught of the incident radiation, no matter how feeble was light, meaning however small the intensity of radiation be, electrons were always emitted. Second observation काय, there was no time lag between incidence of light and emission of electrons. So photocurrent started instantaneously within 10 to minus 9 seconds. On shining the radiation, even if the intensity of radiation was low, as soon as the incidence of radiation was stopped, the flow of current stopped. Okay, third point, keeping the frequency nu of the incident radiation and accelerating potential V fixed. Keeping the frequency of nu of the incident radiation and accelerating potential V fixed. If the intensity was increased, the photocurrent also increased linearly with intensity. Okay. So this is shown in diagram, the photocurrent as a function of incident intensity for fixed incident frequency and accelerating potential. Next, fourth observation. Here again the diagram. Fourth observation. So write down the, draw the figure. So a retarding potential, that is minus V naught. Zero. Okay. So it is photocurrent I. Here accelerating potential, retarding potential and accelerating potential. So here photocurrent minus V naught. So here high intensity, and there is a low intensity. I naught 1, I naught 2, and I naught 3. So photocurrent as a function of accelerating potential for fixed incident frequency and different incident intensity. So photocurrent I could also be varied by changing the potential of the collector plate. So here the photocurrent I could also be varied. So your photocurrent I could also be varied by changing the potential. By changing the potential. So photocurrent I would be varied by changing the potential of the collector plate. I was dependent on the accelerating potential V. So I जो आहे तो काय असणार आहे accelerating potential V वरती dependent आहे. So potential difference between the emitter and collector. So for given incident radiation, intensity and frequency were fixed. So initially the current increased with voltage, but then it remained constant. This was termed as saturation current I. So for given incident radiation, so for given incident radiation, intensity and frequency were fixed. So initially the current increased with voltage, but then it remained constant. Okay? Initially the current increased. सुरुवातीला काय होते करंट काय होतो increased होतो with voltage. But then it remained constant. त्यानंतर मात्र तो काय होतो बघा, but it then remained constant. So this was termed as saturation current. The saturation current. So photocurrent as a function of accelerating potential for fixed incident frequency and different incident intensities. So here, this is the photocurrent I. Okay. This photocurrent I versus its accelerating potentials or retarding potentials. So here, this photocurrent I could also be varied, so change होतो by changing the potential of the collector plate. Collector plate चा असणारा potential आपण change केलं तर साहजिकच त्याच्यामधला photocurrent सुद्धा काय होतो vary होतो. So this is a zero. We accelerating the potential, we increasing the potential, and retarding potential means we decreasing the potential. So initially the current increased. Increased. This is y-axis current, x-axis potential. For given incident radiations. Initially the current increased with voltage. But then it remained constant. After that it remains constant. This was called as saturation current. LS upon काय म्हणतो इथं saturation current and so here photo current I could also be carried by the changing the potential of the electrified plate. So here for given incident radiation, initially the current increased with voltage, but then it remained constant. This was termed as the saturation current. या ठिकाणी बघा इनिशियल करंट वाढत जातो आणि त्यानंतर तो काय झालेला आहे सॅच्युरेशन. दिस इज अ हाय इंटेन्सिटी, दिस इज अ लो इंटेन्सिटी. सो आफ्टर दॅट करंट gets saturated. So I naught is called as a saturated current. So here again photo current is a function of accelerating potential or returning potential. Okay. Next I have fifth observation. Keeping the accelerating voltage and incident frequency fixed. Okay, keeping the accelerating voltage and incident frequency fixed. If the intensity of incident radiation was increased, so here we accelerating voltage and frequency are just kept constant, but if the intensity of incident radiation was increased, the value of saturation current also increased proportionately. So if the intensity was doubled, the saturation current was also doubled. This is a fifth observation. Maximum write down is most important to study. To just read, do not understand or do not perform its perfect point. But whenever we maximum times write down it the points, then we understanding the concept and then it will be write down in exam. So do maximum timing of returns. Okay. So keeping the oscillating voltage and incident frequency fixed. So here we keeping the accelerating voltage and intensity of incident radiations are fixed. Then what happened? If the intensity of incident radiation was increased, then value of saturation current also increased proportionately. Intensity of incident radiation increased, current also increases. So if the intensity was doubled, the saturation current was also doubled. If the intensity जर डबल केली, त्याची इंटेन्सिटी आपण डबल केली असेल, सॅच्युरेशन करंट सुद्धा काय होईल त्याचा डबल होणार आहे. So this is fifth observation. Next, sixth observation. Sixth observation. So maximum kinetic energy of the electrons dependent on the potential V for a given metal used for the emitter plate and for given frequency of incident radiations. If the material is changed or the frequency of incident radiation is changed, then kinetic energy also changed. It did not depend on the intensity of incident radiation. So even for very small incident intensity, if the frequency of incident radiation was larger than the threshold frequency, then kinetic energy from given surface was always the same for a given incident frequency. So sixth observation is that the maximum kinetic energy and the maximum velocity of the electrons depended on the potential V for given metal used for the emitter plate and for a given frequency of incident radiations. If the material is changed or the frequency of incident radiation is changed, then kinetic energy changed. So it did not depend on the intensity of incident radiations. For very small incident intensity, frequency of incident radiation was larger than threshold frequency. So kinetic energy's given surface was always same. Next year, seventh property. The property we studied about the voltage increases, current also increases. Sixth property, saturation current double. Okay, so voltage double, saturation current also double. Then in seventh property, if increasingly negative potential, okay, If increasingly negative potential were applied to the collector, if we increasingly negative potential were applied to the collector, the photocurrent decreased and for some typical value minus V naught. That is, photocurrent became zero. So V naught was termed as cutoff or stopping potential. So it indicated that when the potential was retarding, the photoelectrons still had enough energy to overcome the retarding electric field and reach the collector. So value of V naught was same for any incident intensity as long as incident frequency was same, but was different for different emitter materials. So what is the seventh observation? If the here collector plate is positive, but whenever by using the commutator with changing its polarity, that is it makes negative potential. So here commutator, okay, so it is a firstly positive metal plate. Due to this all electrons are absorbed by the collector plate, but whenever it makes become a negative potential, then electrons are not catched by the collector plate, so electric current will be stopped. But certain minimum property of the electrons which is reaches to the collector plate at a certain potential, retarding potential V naught. Okay, so this is the seventh observation. That is, if increasing negative potential were applied to the collector, photocurrent decreased for typical value of minus V naught and photocurrent becomes zero. So V naught was termed as cutoff or stopping potential. So V naught is called as cutoff or stopping potential. So it indicated that when the potential was retarding, the photoelectrons still had enough energy to overcome the retarding electric field and reach the collector. So value of V naught was same for any incident intensity as long as incident frequency was same and different for different emitter materials. Next, eighth observation. Here again draw the figure. Here again photocurrent as a function of accelerating potential for fixed incident intensity but different incident frequencies for the same emitter materials. So here, eighth observation is that if the frequency of incident radiation was changed, keeping the intensity and accelerating potential V constant. The eighth observation काय आहे? If the frequency, समजा eighth observation मध्ये काय म्हटलं आहे? If the frequency of incident radiation was changed, समजा incident radiation ची असणारी जी काय frequency असेल ती जर आपण बदलली, कीपिंग द इंटेन्सिटी अँड ॲक्सिलरेटिंग पोटेन्शियल व्ही कॉन्स्टंट, काय करून इंटेन्सिटी त्याची काय असेल किंवा ॲक्सिलरेटिंग पोटेन्शियल व्ही काय असेल ते आपण कॉन्स्टंट ठेवू. सो इफ द फ्रिक्वेन्सी ऑफ इन्सिडेंट रेडिएशन वॉज चेंज्ड, if the frequency of incident radiation was changed, keeping the intensity and accelerating potential V constant, then the saturation current remained the same. Okay. So here frequency of incident radiation was changed, keeping intensity and accelerating potential constant, then saturation current remained the same, but stopping potential V not changed. So this observation is depicted the stopping potential V not varied linearly with nu. So for different metals, the slopes of such straight lines were the same, but the intercepts on the frequency and stopping potential axis were different. Okay. So here मी आता फळ्यावरती डायग्राम ड्रॉ केलेलीच आहे. या ठिकाणी एका पर्टिक्युलर नंतर ते काय होणार आहे डिफरंट V01, V02 and V03, that is the returning potential. So this is again here the stopping potential as a function of frequency of incident radiation. याच्यावरती तुम्ही बघू शकता स्टॉपिंग पोटेन्शियल फॉर V नॉट. डिफरंट मेटल्स आहेत, मेटल ए आहे, मेटल बी आहे आणि इन्सिडेंट फ्रिक्वेन्सी आहे. सो मेटल ए साठीचं न्यू नॉट फाय नॉट, metal B साठी nu naught dash phi naught dash. So this is stopping potential as a function of frequency of incident radiation for emitters made by different metals. Okay. So ही डायग्राम तुम्ही ड्रॉ करायची आहे, मला दाखवायची आहे. सो तुम्हाला मी फळ्यावरती काढत नाही, इथं दाखवतो. 2 मिनिटं पकडतो बघा. ओके. द नेक्स्ट आपलं लास्ट ऑब्झर्वेशन याचं जे आहे ते 9th. So here 9th observation is that the photocurrent and hence the number of electrons dependent on the intensity but not on the frequency of incident radiation. Okay. The photocurrent, तर या ठिकाणचा असणारा जो एक मिनिट, the photocurrent and hence the number of electrons dependent on the intensity but not on the frequency of incident radiation as long as incident frequency was larger than the threshold frequency nu naught and the potential of anode was higher than that of cathode. Okay, so 9th observation guy, the photocurrent and hence the number of electrons dependent on the intensity but not on the frequency of incident radiation as long as the incident frequency was larger than threshold frequency, the potential of anode was higher than that of cathode. So this is 9th observation. Okay. Next point जो आहे failure of wave theory to explain the observations from experiments on photoelectric effect. तर तोच पॉइंट आपण काय करणार आहे नेक्स्ट ह्याच्यामध्ये शेअर करणार आहे. ओके, नेक्स्ट पॉईंटमध्ये आपण डिस्कस करणार आहोत. ओके. Okay.